Assalamualaikum warahmatullahi wabarakatuh and good morning.
Waalaikumsalam.
Waalaikumsalam.
Salam saya.
Okay. So we are back to decision logic structure. So the content that we have covered today will be asked during your midterm test next week. Okay, quick recap. What we already learned during the part 1. Okay, during the part 1, what we really look is on the 4 types of decision structure. Ada lagi. Okay, 4 types of decision structure, which is a single selection. Okay, single selection is where there's only one condition, kan? One condition, and there's a statement if the condition is true. There may be at least a statement. At least a statement. It can be more than one statement, but the statement is only will be executed if the condition is true. If the condition is false, nothing will happen. So this is a single selection. And if you look at the algorithms, you will see that if the condition is true, so this is a statement for true lah. Okay, if the condition is true, and then and if. So if, no else. Okay. So then we look at the biselection. Okay, biselection where we have also single condition. Okay, only one condition. Okay, that's why we use only single diamond symbol over here. But in both condition, which is true and false, there's at least one statement. Okay. You will see the else without if, so no condition. If you see else with if, it will follows by condition. Alright. Okay, so we already also look at the multi-selection, okay, where we use more than one diamond symbol, kan? It is not here, kan? For example, like this one, so this is multi-selection, for example, this one have 1, 2, 3, 4. Okay, four decision. Okay, and the last one belongs to else. The rest is if, else if, else if, else if, else. Okay, that's if you convert to algorithm lah. Okay, so this is multi-selection. Okay, not nested. This is not nested, and this is multi-selection. Okay, multi. Nested is the one that we are going to look at today. Okay, so last week, after we look at all the possible structure for if selection, single, bi, and multi, then we also look at the case logic structure. So case logic structure is only applicable if the condition belongs to variable types of integer or single character only. Okay, if the decision involving a float, okay, floating point number and decimal number, or a string, more than one character, so you cannot use case logic structure. Okay, you cannot use case logic structure. Right, so this is what we already covered last week. So this is the algorithm. Okay, actually it is very similar with the if-else condition. The difference is only how we write it down. That's the only difference. So otherwise is similar with else. Otherwise is else. Alright. So in part 2, we are going to look at more on the multi-decision. We are going to look at more on the multi-selection structure, which can be further divided to straight-through logic, positive logic, negative logic. So all this is multi-selection, multi-decision. And we are going to also look at the third. This is nested. Nested decision. Also, in the class of multi-selection. So all about multi-selection, and all is about if. Okay, if statement. If else mati. Okay, so the one that we already covered is actually positive logic. Okay, so this is already covered last week. So the one that we discussed on multi-selection last week is actually we are discussing on multi-selection. Multi-selection for positive logic structure, which is in the form of this one. So this is positive logic structure and the most commonly used decision logic structure. So if you are working after this and you need to design any algorithm related to decision, most of the time you are going to use this kind of structure. Okay, positive logic structure. Of course, we are not calling this as when you are working, maybe your boss said, "Oh, develop a system with positive logic." No, no, it is not like that. But if there involve your system involving a decision logic structure, this is most probably the design that you are going to come out, something like this. If there is a true, you will have at least one statement, and it can be more than one statement. It can be input, it can be output, it can be looping, it can be decision over here. And if it is a false, it will check on the next decision. So this is the positive logic structure, the most commonly used. Okay. So we settle on this, positive logic structure. So we are going to look at the next structure, which is multi-selection straight-through logic structure. Is it clear? My voice clear, class?
Clear.
Okay, Kan saya cakap seorang-seorang sah pula kan? Okay. Okay, straight-through logic. Okay, straight-through logic. Let's go straight away to the example. Okay, let's say we have this very simple problem. Okay, you need to calculate, you need to provide a system to calculate the fees for entering a zoo. Okay, so the fees is based on age, and the condition is given to you. First condition, second condition, and third condition. All right, and then you are required to construct a program for this. So for example, let's say if we proceed with the normal one, the most commonly used, which is the positive logic structure. So these are the answer that we get. Dia copy tak? Let's copy this. Copy this. We put it over here. This is a positive logic structure. Okay, of course we have the if you want to complete the design, we need to have inputs and input. What is the input, class? Anybody?
H.
Yeah, correct. H. And what probably the output?
Charge.
Charge. Okay, correct. Good. Okay, then we have charge over here. Print. Print charge. Don't forget to put the start and end. Alright, so this is a most commonly used positive logic structure. Okay, if you can see, why we put a 2 diamond symbol over here, class? Why don't we put 3? We have 3, kan? Why we put only 2? The reason? Anybody still remember why we put only 2, not 3? Because the last decision we put it as else, and so else, if you want to use multi-selection, if you cannot leave the last statement with the last decision with else if. Okay, if should be ended with else. Okay, so in order to follow these rules, and start with if and ended with else. So you cannot use if, this one, because if you use if over here, you are going to require one more symbol, and then if it is a false, then what you should put over here, kan? So no statement that you can put. Okay, that's why we remove this, and then we replace with else, kan? So else, if you put else, no if, kan? If no if, then no decision lah. That's why else belongs to these parts over here. So if you convert this to algorithm, okay, so this is the algorithm, as you can see. Okay, the algorithms. Okay, this one if, okay, follows by decision, else if follows by the decision, okay, and lastly else no decision, and no decision. That's why over here no extra third decision, because no if, only else. So else is belong to here lah, else. The last decision false, belong to else. Alright, so this one, hopefully this is just a recap for what we already discussed last week. So hopefully everyone still remember this one. So this is very important. And how you write down this one also very important. If you are using decision, how you write down this very important. Okay, you may write down like this. Okay, write it out like this. Panjang ni. Supposed to be 10 over here. Okay. Okay, like this. Okay, or earlier. Okay, earlier we have age less than 65. That one is so correct. But some of you will write it like this, the wrong version, something like this. This is common mistake that you will do. Some of you will come up with this. So if you write down like this, you are not going to get any marks for this decision over here, because this is not understandable by the compiler. So what you need to write down over here, make sure it is a correct expression. The expression that is understandable by the computer, which is something like this. Okay, expression. This is first expression. This is a single expression. And this symbol is NN, meaning that both both expression must be true to make this decision output is true. If one expression, okay, at the left side or right side is wrong, so this condition is going to be false. All right. So how you write down this statement also very important. So this is wrong. Common mistake. So please don't do this mistake. Okay, either you do like this. Either you put it like this. Okay, this is correct. Or like the original version, like this. And this is also correct. Alright. Okay, so positive logic. So what's the difference between positive and straight through logic? Okay, straight through logic is before that, if we got input, and for example, user enter input age is 5, kan? So compiler will check the decision 5 less than 16. So true, right? True, it will exit the condition at all. It is not going to check the next condition and so on. Okay, it will exit the condition set. Okay, do the charge equal to 7 and print charge. That's it. So that is positive logic structure. It will stop checking the decision once the decision is true. Okay, only if this is false, it will check the next condition. If this is true, it will not check the next condition. This is important. So this is positive logic structure. But for straight through logic, if you have 100 decision, for example, if age less than 16, age less than 65, age equal to 10, age equal 100 decision, for straight through logic, it will check every decision that you have in your design. Okay, although the first condition is already true, it will check again. The second one, it will check the third one, it will check the fourth one, it will check all the condition, which is cause your program to be longer time to complete, which is not good. Okay, so why is it checking all the condition? Because the design of the design of straight through logic is like this. Okay, if this is correct, it will enter the next condition. If this is correct, already correct, it's still going to enter the next condition. Okay, let me put it over here. And if you have 3 over here, 3 condition, it will list all 3 condition, not 3 minus 1 anymore. It will list all 3 condition over here. So you have 3 diamond symbol. So age more than equal to 65. So this is a comparison. So let's say the question asks you to use positive logic structure. You will know how to make it. But if the question doesn't mention which structure to use, you don't ever use this kind of structure, which is because this is not good. Okay. So now, if it is false, we go to over here. There's no false statement anymore. Okay. No statement for false. Only true. Okay. So this is false. And if this is true, touch. Then go down here. And go to print. So this is, if it is false, it will go to print. Okay. False. Ni false Ni huruf saya hilang ni. So false, go to print. This is false. This is true, right? This is true. Okay, you see the structure over here. Although, let's say user enter age and user enter age 5. 5 less than 16. True, right? True, charge equal to 7. Although it is true, it still need to re-enter the decision set again. Okay, 5 less than 65. True, right? So you cannot use this. If you are using straight through logic, you cannot use this. Otherwise, you will get charge equal to 10. But the correct one, charge equal to 7 again. So if you use if you use straight through logic structure, so you need to apply this. You cannot use this anymore. This is only applicable if you use positive logic structure. So you need to use this. So if h equal to 5, charge equal to 7. Okay, so this one wrong lah. Okay, this is correct. Sorry, this is correct, but this is wrong. 5 and 5. So both must be correct. So this is wrong. This is wrong. This is false. This is true. So we use and. So the answer is false. So this is also false. And then we print charge, which is 5. Which is 7. Okay. Understand, class? So imagine if you have 100 decisions. Okay, 100 sets of decision. So we go through one by one. Although the first decision is already true, but it still need to check. So this is the structure of straight through logic. Okay, straight through logic. Okay, understand, class?
Yes.
So in terms of algorithms, right? So this is the algorithm. Ni cantik sikit lah, okay? Okay, this is the algorithms. If you see, it is independent. No if, else, if, and if you use positive, if, and then we don't have an if over here. For positive logic structure, we only put an if at the end of the else statement. So, because we treat this as one set of decision. This is positive logic. Okay, but if you compare with the straight through logic, it treat the condition as separate independent condition. So this is one condition. We put an if, and then this is another condition. This is another condition. That's why it recheck all the condition, because it treat it as similar with single selection. This is single selection. This is single selection. This is single selection, and combined together. All right, which is not good. Please don't use this unless you are forced to use this by the question, of course. The question doesn't mention to use any, then go for the positive logic structure. Okay, everyone clear with this one? Straight through logic. Boleh, kelas?
Yes, boleh.
Okay, very easy. I think the most confusing one is the negative logic structure. Negative logic structure. Okay. Negative logic structure is the opposite of positive logic structure. Okay. Let's look at this one first. Okay, compared with positive logic structure. Okay, let me put it side by side. This one. Alamak, dah conteng pula ni. Let me open back. Okay, this one. Okay, positive. Okay, let me put it over here. Okay, it is opposite of the positive logic structure. If you look at positive logic structure, we only have at least one statement if the condition of the decision is true. But for negative logic structure, if the condition is true, we don't have any statements. Okay, we will enter the next condition, but only if the condition is false, we have the statement. So this is opposite with this one. This is true, got statement. This is false, only will have a statement. At least one statement. It can be more than one, kan? It can be input, output, and everything over here. Okay, you see the different, class? That's not the only difference. If let's say you need to convert, the question asks you to convert positive to negative logic structure. So you cannot simply change the flow. You need to also change the condition inside of the symbol. You see, original positive logic, we have h less than 16. But over here, you cannot use h less than 16. You will not get false, kan? For you to get 7. So we need to change this into this, so that if this is false, so you will get charge equal to 7. Okay, let's say user enter h5, kan? h5. If we use a positive logic structure, h5, which is true. So straight away we get charge equal to 7. But over here, if user enter h equal to 5, so this one, what will happen? True or false? H equal to 5.
False.
False, right? So if you stick with the original one, you will get true. Kan? If h less than 16, you put it over here. H less than 15. Let's say you didn't change this. So you will get true, kan? Which is wrong. Supposedly you must get false because you want to get charge equal to 7. So if you don't change this, you simply change the flow. So you are going to get a wrong design. So how to change this? From this symbol to from this operator less than to more than or equal, it is by following this table over here. Okay, logic conversion to change positive to negative or negative to positive. Okay, so let's look at this one and put it over here. Okay. So you can see over here, so originally we have less than 16. So if you have less than, either you use more than or equal, or you use more than. So this is based on case. So in this case, it is more suitable on this one. So we apply this. If your case is more accurate using this symbol, then we need to use this symbol. So either this symbol or this symbol. Okay, if you want to convert from positive to negative, and vice versa. If you want to convert negative to positive, of course, we may refer to this table. Okay, the same table. This is not equal, not equal. Okay, class. Clear? Negative logic structure.
Yeah.
Yeah.
Okay, negative logic structure. So in terms of the algorithms, you see the algorithm is like this, which is nested. This is nested. We said nested decision if the condition inside of a condition there's another condition, then we say that it is a nested decision. Okay, this is a parent decision. So only if this is true, we have another decision. So this is what we call as nested decision, and that's why also writing a indent which one to slightly to the right, and then this is to the right, is very important because it will shows the parent and child. When this is a parent, this is a child. Okay, so you will see clearly if you write down the algorithm. So this is if, and then if this is true, this is true, this is the true statement, this is the false statement. So this is a true statement for this if. So if this if is true, we have the true statement. So all this is belong to this. All this belong to this. Okay. So this belong to this one. This belong to this one. This is the else for this. Okay. This is else for this. This one, don't get confused. This is the else for this. That's why over here, this is the else for this one. That's why the indent is like this, to make it clear for reader to understand. So this is the else for this if. Clear, class? Clear? Okay, let's say if we have 3, for example, this is example. Example lah kan, whatever lah over here x kan. Okay, like this. So how do you want to write the algorithm? False, and this is false. Then we have false. Then this is true. True. And then we combine lah over here kan. Combine over here. 1 point over here. So how do you write down? Where should I put this in the algorithm? In line number what?
3.
Line number 3. Okay, good. Correct So I should put this in line number 3 because this is inside of this one. So this is 3 level nested 1, 2, 3. So we have another line over here. So don't put it in the same line. If you put it in the same line, meaning that it doesn't belong to this one. So if you want to make it belong to the h more than or equal to 65. So slightly to the right. So this one, the condition whatever the condition. And then if this is true, what happened? If this is true,
Charge equal to 5.
okay, correct. So this is belong to this belong belong. Okay, this is belong to here. How about charge equal to 11? Belongs to which one? Which condition? Where should I put this? In line what? Line number? Anybody? Line number?
6.
Correct. Okay, so this is line number 6 So this one belong to this statement. So this statement else This is the else. So the else for this statement. Note this The else for this statement. So put it indent. Indent is very important. So belong to this. So now it is 11 So this belong to which else? This one, right? So in line number what? Line number? Where should I put this?
Seven.
7. 1, 2, 3, 4, 5, 6. 7 this one. 7.
8.
8 Okay, 8. Okay, this is 7 This is 7. Okay, this else belong to this one This else belong to here. This else belong to this statement. This statement. So should be in line and catch equal to this should be in line with this one not with this charge equal to 10. Right. Okay, and then this should be
10.
Okay. So this one should be in line with this one So this is the else for this value over here So else and this one. Okay, charge equal to 7. Right? Then supposed to be an if all the else should be ended with an if See, there will be some marks over here and if and then this one got because it is a different sets of decision and if okay. Else and if got else ended with and if. Alright, so then you got yourself a negative logic structure which also happen to be nested nested decision. Okay? Any question?
No, sir.
Clear? Alright, so no question. In general, this is a comparison. Side by side, straight through logic, independent, if without else. Then we have straight through logic, if else, if else if, and ended with else. Of course, we have and if, okay, and if. And finally, we have the negative logic structure, which happen to be also the nested if, and then we got if, which is the vice, the opposite of positive logic structure. And we use this table, if you want to convert it into positive to negative or negative to positive logic structure. So this is a symbol, the operator that you need to convert to this one. And this is the general of the flowchart. Okay, general structure of the flowchart. Straight through logic. Okay, positive, the common one that we use. Okay, the negative, which is if you compare with the positive, true got statement, negative true got another condition. Only if it is false, it got statement. Okay, true statement, false statement. Right. Okay, next is the nested. Nested is the same. So this is nested. Nested is similar like the negative structure, okay, where we have a decision, and then inside of it we have another sets of decision, and most probably the decision is different sets of decision. Okay, different sets meaning that it doesn't related with the first condition. The condition is, for example, this one, it's about the pay type. The second condition is about anything else. Not pay type, hours, and it doesn't related with the first condition. Okay, so this is nested decision logic structure. Okay, so that's why you see over here, if this is true, if it is a nested, it will go to next condition. Okay, so normal decision without nested, if it is true, it will go to statement and normal statement, input output. But if it goes to another decision statement, so we consider this as a nested decision logic structure. Okay, so actually the one the exercise that you do yesterday is about nested. That's why I asked you to do the exercise, just to make sure you experience, because this type of question might being asked during the test. So you need to get familiar with this. So about yesterday lab exercise. Alright, this one. Ni siapa yang tadi saya buka ni? Nur Hidayati. Are you here, Nur Hidayati? Ada tak? Nur Hidayati? Nur Hidayati? Ada tak? Nur Hidayati. Nur Hidayati. Ada ni? Dia tak jawab. Consider absent Boleh ke? Tak ada. Tak jawab Okay. Then we look at somebody else answer Let's take a look. Muhammad Safwan. Muhammad Safwan ada? Muhammad Safwan? Muhammad Safwan? Hello? Okay, this is a good example of a mistake, common mistake. So make sure if it is a decision, you put a decision in the PC kan. So either you put it over here kan, given data in terms of table kan. For example like this so you put it in the given data, you just list, for example this one list all the condition available. Either you put it over here or you put it in the processing required in terms of something like the algorithm kan. Example from the notes, so something like this so you put it over here. So it's up to you lah. If you want to combine both also, the best lah. The best answer you put it over here and then you put the table of condition over here in the given data. So that's the best lah, the best answer. Alright. So this is missing the condition the decision is missing in this answer. But the input, is it correct class? Input, is it the correct input? So this is incomplete. Okay, wrong because you are missing what over here class? Package, this is quantity and quantity. Should we put price and discount over here guys? As input. Input is the one given by user user need to type so if you user enter price over here so why do you need to do the system you already got the price by yourself no need to enter the system, no need to use the system to calculate for you so this is wrong. Okay, common mistake, you put input and you put output in the given data. Okay, common mistake. Okay, so this is wrong, missing the decision. This is wrong, doesn't cover everything Okay, so this is example of wrong version. Okay, Nazrin.
Ada sir.
Okay, Nazrin. Okay, name, phone number. Okay, of course this is correct name, phone number. Why we need this as input? Because the question give this table over here so you need to follow follows. If manual got name and phone number, supposedly the system also user need to enter name and phone number name, phone number. Ini siapa punya tadi ni? Name, phone number, and then user need to enter the menu menu lah. Menu as in general menu. Okay, this is another example of wrong. Okay. Okay, instead of menu, okay, this is no, this is correct. This is the correct one. Siapa punya ni? Nazrin punya ke? Is this yours, Nazrin?
No.
Siapa punya ni? Okay, however, the things that is wrong over here is not 100% wrong lah, because this supposed to be in general quantity not specifically chicken rice quantity or milk quantity It's supposed to be in general, because if you put it both, meaning that you need to enter both. Is it correct? No, right? It depends on the package that user choose, right? If user choose package chicken rice, so the user doesn't have to enter pre-packed meal kan? Right, class? Is it correct? If user enter chicken rice, user doesn't have to enter the meal, pre-packed meal quantity. But if you put it like this, meaning that it is compulsory for user to put meal, pre-packed meal quantity and chicken rice quantity. No, right? You understand? Do you understand me, class? So the input should be general lah, general quantity. Okay, doesn't matter whether user enter chicken rice or pre-packed meal. Okay, they still need to enter the quantity, okay, based on the package. Okay, understand?
Yes.
Alright, should be in general tadi siapa tadi? Naim tadi Naim Okay, menu type, quantity. And then you have this package A price Alright, so if you put like this, meaning that you want user to enter package A price, package B price. Naim
Sir.
Yeah.
Kalau kita define tak payah.
Tak perlu. If you put it initial as an initial so no need to put in given data lah. Unless if you straight away put the value over here, then you may put it over here For example, package A price equal to what? Then you may put it over here. Apa contoh apa tu? Berapa di value dia? Package A price berapa?
10.
10 So you may put it over here. Then it is okay. But if you put it like this, it somehow you make it input, general input, no value based on user need. User can enter any value. Alright. Okay. Same goes to here. So this is output this is also from the system. So this is okay, and then the output. Apa output dia? Ada soalan Okay, the output, is it mentioned anywhere? Ni calculate the price before discount, discount amount, and price after discount lah. So highlighted over here, it should be the output lah. Okay, 3 at least 3. If you want to have extra, then it's up to you lah. But this 3 should be presented. If some of you put name and phone number as output as well so that one is okay but maybe not counted. Maybe because doesn't mention tak ada mention doesn't mention in the question. Doesn't mention in the question, so it's up to you lah. But this 3 should be presented. Okay, output and then we have over here. Okay, you put it like this. Okay lah. Okay, correct. This one, some of you write down the name of the menu also correct chicken rice ke. But make sure if you put down a string chicken rice for example chicken so make sure you use this Okay, A pun same goes to A. So this is character character we use this for single quote for character. Only if you put number, for example, menu type 1, then you may put as a number lah. Number doesn't have to have the quote. Alright. And then okay, we have the why we have nested over here? Because if you refer back to the questions, okay, the question specifically give you this table. You can see straight away The discount first is the main condition, which is the price. Okay, to determine the price based on the package. So if package chicken rice, this is the price. If package pre-packed, this is the price. But inside of it, okay, inside of this, there's another condition. If order for chicken rice more than 100, then you got discount. Else, no discount, right? Same goes to this one. This is specifically for this one. Inside of this, another decision. So this is easy since the table is given to you. But let's say if all the information is given inside of a paragraph, a text paragraph, inside of 10 sentence. So you need to be able to extract this information, and just note it down in the form of table so that it is easier for you to digest the information. Kan table kan senang sikit. Okay, so we clear that we have two sets of condition, but these two sets condition is in the form of nested lah, because this is inside of this one. So this is good answer. So you figure out it is a nested, and then we have the calculation lah. It's up to you. Because the calculation is similar. You may have more than one answer actually for this. Some of you put the calculation after the decision, also correct kan? No problem. You can have more than one answer over here. Okay, but the thing that I want to stress over here is the nested part lah. Okay, the nested. This one no. Why constant? It's not constant. Is it constant? Or you choose this one? Constant value. Okay, this one okay lah. Boleh acceptable. Fixed value. Okay. Alright. Let's look at the clear. This is much more clear. Okay. Okay, good. Okay, good. Menu type, location. Okay, this is good. Menu type. Okay, you see, this is decision. And then inside of it, we have another decision. Okay, acceptable. But if you have more than one equation, don't combine all equation within a single symbol. If it is a input and output, yes, you may combine, but for calculation, use separate symbol. Understand? Meaning that over here kan, so you have one equation, two equation, three equation kan. So separate the symbol. Use three symbol lah. 1, 2, 3. Okay, Naim Okay. Okay, good. So in this question also mention this one kan. Okay, first we have this, and then in the E part, so we have additional decision, which is not nested. You see, not nested. So not nested. Don't put it anywhere inside of the the rest of the condition. So it is not nested. That's why you see our friend over here, Naim, answer. It's very good. It is not nested. It is after we got the join. After all the arrows join together, then it enter the next condition, because it is not nested. That's why we got this. Very good. Okay, good. This is a good example. Anybody else got different kind of answer? Ada? Fakrullah. Ada Fakrullah? Mana Fakrullah? Tak siap ni. Next week midterm test for those who still blur tu kan, make sure apa make sure you study hard lah. Because next week. So this one, okay, this is wrong. If you have something like this, if you have a choice should be in form of decision. But this is wrong. Enter chicken rice, enter pre-packed meal. This is wrong. Flow kan. The flow is very important. If you want to check your flow, just read and then read lah your flow chart. Start. So need to go where kan. If you have decision, make sure use proper decision symbol. So this is wrong. This is wrong. Kita tengok 2A Kan Nirop.
Yes, sir.
Okay, alright. Okay, missing 2 more. Name and
phone number.
phone number. Okay. Package chicken rice. Okay, good. So we got the nested over here. Okay, same goes over here. Use a different symbol for each of the equations. And then meet again over here. Alright. Okay, but this is no output Europe you are missing.
Yes, sir, I understand.
Okay, it should be print something over here.
Yes, sir.
Right.
Print and then int.
Yes.
Okay, sir.
This is same structure. I would like to see maybe different. Ini last week ni. Mana ni Zamil? This is last week. Ili.
Yes, sir.
Where's the condition? Ili.
Yeah?
Mana? Decision. Input, decision. This is sequential. Display is not right. This kan. Symbol display macam mana? Print kan. Parallelogram. The symbol is wrong. Decision ni tak ada ni. This is wrong. Okay. Adriana.
Yes, sir.
Okay. Not okay. So this is expression If you put expression so how do you want to, this is for what? This is to calculate what?
Price after discount.
Price after discount.
Yes.
Price after discount calculation, right? So okay, let's say yes kan. Over here quantity 200, yes. And then calculate this. And then how to calculate this? Do you understand?
Ya, tersilap lah tu.
Supposedly what? Supposedly? Supposedly? Because if you put like this, the value is not being stored anywhere. Okay, so you cannot calculate this one. Okay, you will not get this value. Understand So make sure it is equation lah. Equation price after kan. Price after equal to 0.1 multiply price before, and then what is discount? This is to calculate discount discount lah. Discount equal to, then you get the value of the discount, and then you can calculate discount over here. Otherwise, what is the value of the discount kan? You don't have it.
Oh, alright.
Okay.
Okay.
Yeah, this also use proper operator. You want to compare kan? If chicken rice, if what chicken rice? what's the
menu type.
Menu type equal to chicken rice kan? Use proper symbol lah. This is also similar.
Alright. Sorry, sir.
Location Okay, in general the structure is correct, but the content of the ni lah, simbol tu kena perbaiki lagi. Okay, Nurul Afidah.
Yes, sir.
Okay, this is another version alright. Enter package. Okay, package. If this package is chicken rice, true. Quantity. Okay. Okay, boleh. But but you may simplify it kan, because this is redundant kan. Read quantity. Both condition true or false also need to read quantity kan. So why not just put it only one kan? Put it before kan, because both condition need to read quantity. That's right. So you may combine, but this is also correct. Correct, but you may simplify.
Okay, sir. Thank you, sir.
Okay. Ohua?
Yes, sir.
Okay, this one combine. Combine straight away. You may combine, but not like this. Okay, if you combine, you need to consider all the possible combination. You understand me? This one menu type equal to chicken, and then what? You want to combine with rice. Is it or and? Or and?
And.
And. If true, this one. If false, this is confusing. This is go where? And okay, true, price discount. Okay, this is acceptable. I think this is acceptable, but use proper symbol and okay, acceptable. arrow lah, arrow. This is supposed to be, you know, make sure when people read, people don't get confused. Okay, I think acceptable. Charge. Okay, calculating the total charge. Okay, okay. Alright, boleh. But use a proper symbol.
Okay, thank you, sir.
Okay. Royston.
Yes, sir.
Menu type. This is not variable Royston. If you put this is value kan, not variable so value lah, value chicken rice kan. Comparison symbol equal comparison But usually when we do the system kan, we as much as we can, we avoid user to enter too many things. For example, like this kan, you need to enter chicken rice kan. What if user enter chicken with R, capital R? So it will not detect kan. So usually we define a menu type. For example, 1 for chicken rice, 2 for pre-packed meal kan. So it must be easier for user to use the system. Okay, true. And false. Okay, calculate the price. Okay, and this to define the discount. Okay, boleh? Okay, acceptable. Delivery charge. So what's the point for delivery charge over here? Because you are not using it. Are you using it anyway? Delivery charge equal to 20. No, right? If you want to put it like this, it should be over here lah. Delivery charge. Kan? Betul? Understand? Is it like
Betul,
this?
sir.
Okay, boleh. Okay. Sarah. To charge my laptop. Ada Sarah. Sarah here?
Sir, I don't finish yet.
Okay, apa ni siapkan
Okay, sir. Sorry, sir.
Sitway mean?
Hello.
Okay, looks okay. Okay, I prefer something like this. Okay, I prefer this kind of answer actually. Okay, because it is easier to read. But please, we mean not like this. Supposed to be true and false. Okay, true. Okay, and then you put price. And then this one also true, false. This is discount. And then you do the calculation. I prefer something like this. But this one need to be separated. Use different symbol for each of the equation. Okay, final price. Alright, good. Okay, good.
Thank you.
Right. So you see, class, we got more than one. Aduh, mute. You got more than one correct answer actually. So as long as your answer is correct, then this is okay. So how to know your answer is correct or not, kan? So go through the flow one by one. Doesn't matter whether it's a flow chart or algorithm. You need to test. You need to test your design starting with start. And then try it. So let's say if this is the input, is going to get the correct output at the end of the design. If you got the correct output, then your design is correct. Okay. Alright. Anything to ask, class? Okay, regarding today's topic, part 2, straight to logic, positive, negative, and especially the nested. Anything to ask?
Saya tanya.
Ya.
Dekat solution alternatif ni, macam mana kadang-kadang kita nak pilih constant, kadang-kadang pilih input value.
Okay. Okay, just go for the input value lah, guys. Okay. Just the solution alternative, let's say in your design, you have both constant and input, okay, just list down the inputs one. No need to go, don't list everything. Just list, for example, this one, hours and rate, define hours and rate as constant. Define hours and rate as input value. Then choose the input value. Okay. But let's say if you want to focus on constant, this got hours and rate, and you have apa? You have this we focus on the input, as I explained earlier. This we focus on input. Let's say if you have constant, time equal to 100, constant, then you put time over here. Define time as constant. Define time as input value. Then you put star in front of constant, because you focus on time, kan? Choose either one. Boleh? Menjawab tak?
Okay, faham.
Boleh? Okay. Alright. Okay, any other question? Okay, if no, then if you go to the lab exercise, kan? So in question 2, question 2 is question related to the positive and negative logic structure. Alright, so I want you to, we have another about 40 minutes left. Okay, answer question number 2 and update your answer in the lab. Okay. So if you have finished until you finish question 1, okay, just open back your answer in question 1, and below the answer of question 1, write down answer for question 2. Okay, if you finish everything, save your answer and resubmit again in the same link. In the same link as what you submitted yesterday over here. Okay, just resubmit again. Okay, boleh kelas?
Boleh.
Alright. Sekejap. So let me create the attendance first. Macam tu kan. Okay, fill in the attendant. Okay, link provided in the chat. And then you may proceed with the exercise. Okay, class, thank you. Assalamualaikum.
Thank you, sir.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.